If you were to, say, walk into a massive commercial greenhouse right now, you would probably look around at the thousands of these perfectly uniform blooming plants and, well, you'd probably assume you were looking at a nursery full of youth.
Oh, absolutely. That's the natural instinct.
Right. You'd see row upon row of small, vibrant green stems just bursting with flowers. And it's so natural to think, look at all these brand new young plants.
Yeah, the new generation.
Exactly. But you would be entirely wrong. You are actually looking at a room full of biological veterans.
It's wild to think about.
It is. These are plants that have been fundamentally tricked into skipping their own childhoods completely.
It is such a brilliant illusion, really, because when we decide to grow something, whether we are planting, I don't know, a single tomato in the backyard or trying to scale up a massive agricultural operation, we're just conditioned to accept the waiting period.
Right, the waiting game.
Exactly. We assume that growth is this linear, unskippable process. You put a seed in the dirt, you water it, and then you just sort of endure that long, slow climb from the starting line.
You pay your dues.
You do. You pay your dues, watching the leaves slowly form, hoping that eventually, months down the line, you get a bloom.
Which is, that's the standard narrative of nature. But today's deep dive is about throwing that standard narrative completely out the window.
It's completely out the window.
We are unpacking this really phenomenal piece of source material today from a series called Notes on Gardening. Specifically, we're looking at part 953.
Yes.
It's written by an author named Ang, and the title really just lays out the thesis right there. It's called The Profit of the Tip, Efficient Floral Propagation.
And it is a remarkable document because Ang isn't approaching this from the perspective of, a casual weekend hobbyist.
Right. This isn't just backyard gardening tips.
Not at all. The insights in this text are pulled directly from these extensive field trips to commercial plant nurseries, which are then cross-referenced with Ang's own meticulous hands-on propagation experiments.
It's very rigorous.
Highly rigorous. Ang is basically looking at botany through the ruthless lens of operational efficiency.
And that is the core mission of our deep dive today. We are going to extract the exact biological mechanism these high-level commercial nurseries use to just radically speed up their production cycles.
It's basically a biological cheat code.
A biological cheat code, yes.
Yeah.
And it's a mechanism that is beautifully simple, yet it completely dismantles how we traditionally think about the lifespan of a plant.
That really does.
But to really grasp the value of this cheat code, we have to first strip away the romance of gardening and look at the brutal reality of the commercial nursery business.
Yeah, we have to look at the math because a commercial nursery is, at its core, a factory. And space in that factory is exceptionally expensive.
Right, the overhead is massive.
Massive. Every square foot of a climate-controlled greenhouse costs money, to heat it, to light it, to water it, to staff it.
Yeah.
So if a plant just sits on a bench for 6 months doing nothing but slowly growing structural leaves, well, it is actively draining the nursery's profit margins.
The clock is always ticking. The overhead is constantly running. So the primary metrics for survival in that industry have to be turnaround time and volume.
Exactly. Turnaround and volume.
The ultimate goal isn't just to grow a plant. Anyone can grow a plant. The goal is to get a flowering plant onto a retail shelf as fast as biologically possible. Because consumers, and you know this if you've ever bought a plant, consumers buy flowers. They don't just buy green stems.
They want the color.
Yeah.
And this is exactly where Ang's field observations become so crucial, because Ang noticed a really distinct pattern across all these successful commercial operations.
Okay, what was the pattern?
Well, when these nurseries want to exponentially increase their inventory of flowering plants, they do not plant seeds.
They skip the seeds entirely.
Entirely. And they don't just take random cuttings from the woody base of an existing plant either.
Right.
The absolute most efficient approach, the industry standard that Ang outlines, is propagating using what are called tip cuttings.
The tip cuttings. Okay. So we are talking about going to a fully grown parent plant and exclusively harvesting from the very ends of the branches.
Just the very tips.
Right. And Ang points out that this specific method leverages something called terminal growth. So by focusing solely on this terminal growth, nurseries are essentially buying themselves a massive head start in the production cycle.
They are, because that terminal growth is the absolute front line of the plant's biological engine.
The front line.
Yeah, it is the newest, most active tissue pushing upward and outward. So the nursery isn't just taking any green material. They are being highly selective about taking the specific tissue that is currently dominating the plant's resource allocation.
Now, I want to push back on this a bit, if that's okay.
Sure, go for it.
Because when I was first reading Ang's notes, my immediate thought was, a cutting is a cutting.
Right, a stem is a stem.
Yeah, like if I take a 4-inch piece of stem from the top of the plant, or a 4-inch piece of green stem from the middle of the plant, they are both just detached pieces of the exact same genetic material.
That's true.
So why would the plant care which part of the stem it used to be? I mean, how does the top piece know it's supposed to be on some sort of fast track?
See, that is the pivotal question. And to answer it, we really have to move past the genetics and look at the chemistry of the plant.
The chemistry.
Yeah. While every cell in that plant shares the exact same DNA, they do not share the same chemical instructions.
Oh, interesting. Okay.
Think about the older stems lower down on the plant. They have essentially retired from active vertical growth.
They're just holding things up.
Exactly. Their primary job is structural. They are the scaffolding. So if you take a cutting from that lower scaffolding, it has to completely reprogram itself.
Oh, I see.
It has to wake up all these dormant cells, slowly generate brand new growth tissues, and painstakingly build a completely new upward trajectory.
So it's essentially starting from scratch. It's like trying to build a catapult, but first you have to go chop down the tree to get the wood.
Oh, that's a perfect analogy.
You were just so many steps away from actually launching the projectile.
A perfect way to frame it. But the tip cutting that terminal growth is a fully tensioned catapult.
It's ready to go.
It is actively in the process of growing. So when nurseries selectively harvest that front line, they are tapping into a part of the plant that is already chemically instructed to push forward.
Which obviously shaves weeks, if not months, off the entire production timeline.
Oh, absolutely.
And this brings us directly into the biological mechanism that makes this whole system operate right. Because the secret to this extreme efficiency isn't in some highly classified root-stimulating powder or proprietary greenhouse fertilizer mix.
No magic potions.
The secret is entirely contained within the specific physiology of the cutting itself. And Ang uses a brilliant phrase here in the text. Ang describes these tips as being physiologically primed.
Physiological priming. That is the engine of this entire operation. Ang breaks down the biology, explaining that these specific terminal tips are primed for reproduction because they are utterly packed with mature growth hormones.
I really want to linger on that phrase for a second. Mature growth hormones. Because this completely changes the paradigm of what a new plant actually is.
It does. It shifts the whole perspective.
Think about it. When we plant a seed, that seed contains the blueprint for growth, sure, but it doesn't have the mature chemicals yet.
Yeah, not
that it has to, build a factory, source all the raw materials from the soil, and then slowly manufacture those mature hormones over this long, drawn-out juvenile period.
It basically has to go through puberty, essentially.
Yeah, exactly.
A seed-grown plant must spend massive amounts of energy just reaching biological adulthood before it can even think about reproducing or flowering.
Right.
But the tip cutting bypasses that entire life stage. It doesn't need to build the hormone factory because it is the factory.
Wow.
It already possesses all those adult, ready-to-work chemical messengers. So once you sever that tip, place it in the soil, and just allow it to establish a rudimentary root system, it doesn't revert back to childhood.
It just keeps going.
It uses those mature hormones to trigger immediate floral production.
Which sounds incredibly efficient. But reading through Ang's specific instructions on how to actually harvest these cuttings, I ran into a massive, glaring contradiction.
Oh, I know exactly what you're going to say.
I really need to unpack this with you. Because the entire premise here, the whole reason these commercial nurseries are running this intense operation, is to produce and sell flowering plants.
Right.
But Ang explicitly insists, in no uncertain terms, that you must take the cutting from the non-flowering tip.
It seems completely counterintuitive, doesn't it?
It feels entirely backward. Like if my ultimate goal is to have a flower, and I am holding a pair of shears, looking at a plant that currently has a beautiful bloom on one branch, and just a plain green tip on the other branch,
You'd want the flower.
why on earth would I actively avoid the part that has already successfully produced a flower? Shouldn't a flowering tip be the ultimate head start? It's already doing the thing I want it to do.
It is a very natural assumption to make, but it fundamentally misunderstands how plants budget their energy.
Okay, correct my assumption then.
This is actually, I think, the most elegant piece of logic in Ang's entire thesis. It all comes down to the brutal economics of potential energy versus spent energy.
Okay, so walk me through the balance sheet of that energy. How does that work?
Well, we have to reframe what a flower actually is. To us, a flower is decorative. It looks nice on a table.
Right.
But to a plant, a flower is the absolute most exhausting, resource-intensive undertaking of its entire life cycle.
Really?
Oh, yeah. A flower is the final stage of a massive expenditure of energy that's designed to attract pollinators and create seeds. So by the time you actually see a bloom open, the plant has already cashed the check.
Ah, I see. So the mature growth hormones have already been used up to trigger that specific event.
Precisely. The reproductive event has occurred. Now, imagine you take your shears and you cut that actively flowering stem off the parent plant.
Okay, clip.
You have just severed its only source of water and nutrients. But that flower doesn't know that. It is still transpiring, it's still demanding massive amounts of water just to keep its petals hydrated.
Oh, wow. So the cutting is suddenly thrown into a state of absolute panic.
Utter panic.
It has this incredibly demanding flower draining all its resources, but it has zero roots in the soil to pull of any replacement water. It is completely overextended.
It's basically trying to run a marathon while simultaneously trying to build the skeletal structure of its own legs.
That sounds terrible.
It is a biological disaster. The cutting will almost always abort the flower anyway just to survive. And because it exhausted all its energy trying to maintain the bloom in the first place, it will take weeks to generate new roots. You haven't gained time, you've actively lost it.
Okay, but the non-flowering tip, that is a completely different economic situation then.
Exactly. When you select the non-flowering tip, you are capturing a massive reserve of unspent potential energy.
Unspent?
Right. That tip is fully loaded with mature growth hormones, but the chemical trigger to bloom hasn't been pulled yet. The energy is just held in suspense.
Like a loaded spring.
Yes. It is a seamless continuation of the parent plant's reproductive cycle, just paused for a crucial moment. So when you place that non-flowering tip into the soil, it immediately recognizes its deficit.
It knows it needs roots.
It realizes, uh-oh, I have no roots. So it takes a small portion of its stored energy and rapidly pushes out a root system. And because it wasn't wasting resources trying to keep a heavy flower alive, those roots establish very quickly.
And the second that infrastructure is in place, the moment those roots can pull water, the spring releases.
Down.
All that stored potential energy, all those mature growth hormones are unleashed perfectly on cue. The plant immediately shifts away from establishing itself and just aggressively pushes into vertical growth and floral development.
Exactly. It finishes the job it started on the parent plant.
You are effectively hijacking the parent plant's hard-earned maturity, holding it in a brief holding pattern while the physical infrastructure is built, and then just letting it run wild.
It's brilliant, isn't it?
It's so brilliant. You skip the juvenile phase, you avoid the trap of the spent energy from the flower, and you just hit the fast-forward button.
Yep.
But, what elevates Ang's notes from just a theoretical biology lecture into something truly actionable is the real-world proof. Because Ang doesn't just ask us to trust the mechanics of growth hormones blindly.
No, Ang brings receipt.
Ang provides a very specific case study.
The Blue Porterweed.
The Blue Porterweed, yes.
Scientifically known as Tachytarfeta gemmacensis.
Tachytarfeta gemmacensis. Say that 3 times fast.
I won't even try. But it is a fantastic subject to prove this concept because of how it naturally grows.
And Ang details a specific personal experience propagating this Blue Porterweed using this exact non-flowering tip method. And there's a moment in the text that really cements the reality of this cheat code.
Oh, the photo.
Yes. Ang describes a photo, actual visual evidence of a Blue Porterweed cutting that managed to bloom at a remarkably, almost comically small size.
We are talking about a cutting that has barely established its root system. It's physically tiny, yet it is already pushing out a full, complex floral structure.
Which completely shatters our standard expectation of what a plant that size should be doing. I mean, if you had planted a Blue Porterweed seed, a plant of that identical physical size would be months away from a bloom.
What?
It would just be focused on making a few structural leaves. But this cutting is operating on a totally different timeline.
Because it isn't acting its size, it is acting its chemical age.
Let me try an analogy here. Imagine you're launching a brand new branch of a company.
Okay, I'm with you.
You rent a tiny, bare-bones office space. You've got, like, a folding table and one working outlet. That tiny, sparse office is the brand new root system of our Blue Porterweed cutting.
Barely functional.
Right, the infrastructure is barely there. Now, if you hire a brand new intern to run that office, which would be our seed, they're going to spend the first 6 months just figuring out how the phones work.
Oh, for sure.
They are learning the absolute basics of the business.
They are trapped in the juvenile phase.
Yes, exactly. But instead of an intern, Say you transfer your most senior veteran executive from corporate headquarters, and you put them in that tiny office. That executive is our tip cutting.
Ah, I see.
Even though their surroundings are brand new and incredibly small, their internal experience is vast. They possess 20 years of industry knowledge, or, in the plant's case, a massive payload of mature growth hormones.
Right. They don't need orientation.
No, they skip orientation entirely. The second they sit down at that folding table, they start executing high-level corporate strategy. They start closing deals immediately.
And for the Blue Porterweed, closing deals means pushing out flowers.
Exactly. The physical size of the root system does not dictate the behavior of the plant. The chemical maturity of the tip does.
And that analogy perfectly illustrates Eng's observation that the cutting is simply a continuation of the parent plant's reproductive cycle.
It's just continuing.
Right. The veteran executive didn't become a different person when they changed offices. They just continued their career in a new location. The Blue Porterweed cutting isn't a new baby plant deciding to grow up fast. It is a fully mature adult that just happened to get a new set of legs.
A new set of legs. I love that.
Once those roots are set, it doesn't waste a single day reliving its childhood. It directs everything straight into floral development.
And when you scale that up, the efficiency is staggering.
Yeah.
I mean, if you are a commercial greenhouse operating on razor-thin margins, you do not want a facility full of interns figuring out how to grow leaves.
You go bankrupt.
You want tens of thousands of tiny veteran executives. You want thousands of these blue porterweeds operating at peak efficiency, utilizing their mature hormones to bloom at a fraction of the normal size so you can ship them to market and clear the bench for the next batch.
It is the ultimate optimization of space and time. You are maximizing output while minimizing the overhead required to reach that output.
So, synthesizing all of this from Eng's extensive notes, whether you are managing a 5-acre commercial greenhouse operation where every day counts toward the bottom line, or you were just, standing in your kitchen with a pair of scissors trying to propagate a houseplant to give to a neighbor.
Right, the scale doesn't matter.
Exactly. The biological rulebook is exactly the same.
The directive is incredibly clear.
No.
You always, without exception, target the non-flowering tip of the terminal growth.
Because by selecting that specific piece of the plant, you are capturing the maximum amount of mature growth hormones while avoiding the massive energy deficit of an existing flower.
We bypass the entire juvenile growth phase.
You are taking the fully tensioned spring, giving it a place to anchor, and letting it fly.
It really highlights how deeply mechanical nature can be when you actually understand the chemical levers that drive it. It's extreme efficiency, just hiding in plain sight on the end of every branch.
It really does completely change how you look at the plants sitting on a nursery shelf. You'll never unsee the veteran executives now.
Definitely not.
But before we wrap up this deep dive, Eng's concept of the cutting being a direct continuation of the parent plant's reproductive cycle opens up a really fascinating philosophical door.
Oh, I like where this is going.
It's a thread I want to leave you, the listener, to pull on a bit.
The intersection of botany and philosophy. Let's hear it.
Well, think about that tiny, newly rooted blue porterweed sitting in its little pot. We've established that chemically, biologically, it possesses the exact same mature hormones and the exact same developmental age as the giant parent plant it was clipped from.
Right. Same age, chemically.
It didn't start over, it just picked up right where it left off.
Hmm.
So at what point does it actually become a new plant?
Oh, wow. That is the botanical ship of Theseus right there. If every chemical impulse in that cutting is just an uninterrupted continuation of the original plant's life, are you actually growing a new individual? Or have you just physically teleported a piece of the old plant into a new pot?
Are we witnessing a birth, or are we just witnessing a change of address?
That is a wild thought.
We spend so much of our lives accepting that waiting period, assuming that every new endeavor requires us to start from scratch and slowly build up to the bloom. But Eng's field notes prove that sometimes the biology doesn't want to wait.
It already did the waiting.
Exactly. Sometimes the most efficient way to move forward isn't to start over, but to cleverly hijack the momentum you've already built. It's something to mull over the next time you find yourself staring at a project or a garden, just waiting for it to finally show you some color.